All right. Hello, everybody. Welcome to wasmCloud Wednesday on Wednesday, June 21st. We've got a demo-packed agenda today. We're actually going to move a couple of things around, but we're going to start with two demos to kick off the call. And then we're going to talk about a discussion item, which we've kind of kicked off before in a few scattered issues and/or community calls, but I really want to set aside some time for us to brainstorm and talk about the secrets in wasmCloud applications discussion. I think this will be a really interesting one to go through. So let's go ahead and get started. I have the first demo here titled wasmCloud Azure Webhooks and Auto Updating OCI URLs. So let me go ahead and give you a little bit of motivation around what this demo is going to solve. So we've had a decent problem in the wasmCloud ecosystem where we have some official capability providers and example actors that we publish to Azure Container Registry, or just as a WebAssembly module or a capability provider. And Azure CR natively doesn't support unauthenticated content discovery as an OCI registry. It's an optional part of the spec. I guess they implement it for people who have, authenticated access to the registry. But you can't go to wasmcloud.azurecr.io and look around at the different things that we have published. So we've had kind of a halfway solution in place for a little while here in the capability providers repo. There are these shields.io, which if you haven't seen this before, you've probably seen it in any README. I'm going to actually change this. You've probably seen it in a bunch of different READMEs across open source organizations. If I can just show, this kind of format. It's called a Shields badge, super useful. And so what we've been using is the dynamic JSON badge, where you can essentially use their API, provide a custom, their payload, and it will give you a nice little layout here for the capability provider URL. So next to all of our capability providers, we have this nice little badge. It actually uses pretty sure this is the common or simple icon for wasmCloud, which Jordan helped push through as like an official icon you can reference to, which is really cool, in the URL and all of that. Now, the problem with this is that READMEs in GitHub, I don't know what other platforms have, but the Markdown doesn't really have the ability to run a custom piece of code. Like, you can't put JavaScript in here like you can in MDX. So you can't have something that auto updates based on when we push a tag to GitHub, for example. So essentially what it was up to us to do is whenever we published a new version of the capability provider, we would have to either update this or, just a couple of months after I set up this project called OCI Refer, and it used a very sophisticated algorithm in order to keep track of to actually keep track of the OCI URLs. So if you look at the contents of this wasmCloud actor before, we effectively had it's an actor that implements the HTTP server contract. We had a Shields. This is the kind of payload that Shields expects, where you have a schema version and a message and a logo. So we have the wasmCloud logo and all of that. And then here's the AI algorithm for determining the latest provider version, aka me hard coding it in the actor and then updating it whenever we publish a new OCI version. So this kind of saves us from having to publish a commit whenever we change the URL in the provider's README, but it doesn't really solve the problem. So last week, I kind of got to thinking, and I actually got around to a suggestion that Jordan, who's here in the call, gave me a long time ago, which is the fact that Azure in their container registry has a webhook that you can call after it pushes a new image version to Azure CR. So effectively what we have now is whenever we push up a new capability provider or an example actor to Azure, it will send this payload to the newest OCI Refer actor, which has a list of endpoints that it supports. And I'm happy to jump into some of the different ones there. but notably the one that we care about is the Azure webhook one. So we deserialize that payload that Azure sends. And from that, we actually have enough information to get the latest OCI URL with the host, which is wasmCloud azure.cr.io, the repository and the tag, which is the provider, and then the actual version. And then we can use the key value contract to actually just store that into a key value store. So this actually worked really, really well from the beginning. I hadn't really used many different projects that have webhooks that quite work like this, but the Azure docs were pretty helpful. It offers a little way for you to send a test URL. I'm just hosting my actual actor in Cosmonic to make it easy to like expose that publicly. Let me show you some of the things that it can do. So the first easy endpoint is that if you actually send I can zoom in a little here, if you send a curl request to this Cosmonic URL, you can actually ask it for any version of a recently published thing that we've pushed for wasmCloud. So if we ask it for the HTTP server URL, it'll respond with the payload format that shields.io expects. This is so that we can pretty much display that nice looking badge in the README because it's technically an image. You know, it's all kind of a workaround to show a dynamic content in a markdown file. We can ask for things like HTTP client, even some of the new example actors like the actor-to-actor call ones, Pinger and Ponger, are both available there. So really the main endpoint that we can use here is fetching an OCI URL. We can also post at this with an authentication token and all of that to add in new capability providers. But one thing that I set up additionally is this notion of categories. And I think this is going to be really useful. We can use the same actor, the same kind of data store that's coming right out of Azure in order to fetch all of the official capability providers. So this one, it's the /category endpoint. If you give it a payload with the category name, which this is all just kind of set up manually, this will actually give back every single official wasmCloud capability provider with the name and the OCI URL. And then I think I also set one up for actors. Yep, which just includes Pinger and Ponger for now. But this effectively gives us a way. I know that it's been it's kind of a fun gag when we get into it's kind of a fun gag when we get into demos and things like Taylor is going to start the newest key value store and he says, "Oh, Brooks, what's the latest version of KV Redis?" Like it's fun during a demo, but really what it speaks to is the discoverability of our capability providers. And so having them auto update in the README is really important to just have a place where the latest always is. And then I'd love to actually kind of use this to create something like in Wash where we could do some kind of autocomplete, or we could have an official list of capability providers that's auto updating, something that's really robust. So we're not like parsing it from a GitHub tag and then assuming that it made it into Azure CR. Like this webhook fires whenever a new image is pushed, which is really, really handy. So happy to kind of show a little bit more around the code, like effectively what's all that's really happening here. And the reason why it was so easy to develop this is because of the wasmCloud abstractions. Like I didn't have to bring in HTTP server clients or key value store like libraries or anything like that. All I had to do is do a nice little match on an HTTP request. And then when the Azure webhook comes in, a little deserialize, form up the actual reference for the OCI URL. And then I call this store reference function, which is just a little bit below. We just use a key value sender and we set that name of the capability provider and the value is the OCI URL. So it's honestly a really simple solution and probably should have carved out some time earlier to get this done because, I think Jordan probably suggested this webhook thing to me, I don't know, maybe 6 months ago. And I thought it would just be, kind of hard to set up but it really ended up being pretty simple. I was able to test this locally using Redis. And then when I actually pushed up to Cosmonic, I was able to use like that key value store and nothing had to change, yada, yada, yada. It was all pretty fun. There's also, git, delete kind of things for the categories. So yeah, I just wanted to show off this pretty cool, this new actor. I actually wanted to officially show it updating a badge, but I refreshed this page on accident this morning when we released the 0.18.2 for HTTP server, but it super works and it's pretty clean. And so I definitely wanted to show this off. Now, I'm going to be working on a blog post to talk a little bit more in depth of like the process of building this and maybe other things that you could do, like maybe a more common webhook pattern. But for now, you guys get the cool demo. Anybody have any questions?
We're ribbing you a little about having a body on your Git.
I know. I was looking at I saw that in the chat. So the question was, why do you have a Git endpoint with a body? Which is a good point. And I mean, the nice thing is that the one that's set up with Azure is a post. So real with a body, but I could change that. The information that we're querying around just like a category and the name could easily be a query string for sure. I actually did mess around with, I did actually take this actor and all of its endpoints and feed it into GPT and say, hey, can you generate an OpenAI spec for me from this? And it actually did a pretty good job. So one thing that I'm looking at experimenting with is, or Open API, thank you, generates an Open API spec for this actor, which I think would be a pretty cool thing to include with the actor itself because it's mostly an HTTP API. So we'll see how that goes. All right. Well, then I guess if there are no more questions and nobody else wants to rib me for saying this wrong thing or setting up a Git endpoint with a body, I think we can move on to Bailey, which has, all as usual, a much cooler demo than all of us could put together. So Bailey, go ahead.
Not at all. Mine is a Hello World demo, but it's Hello World of stuff you might not have ever seen before. So wasmCloud, of course, builds on WebAssembly and WebAssembly standards. And there's a new WebAssembly standard called the component model that I've talked a lot about through past community calls. And Roman has been working towards having basically a component first enabled Rust host, which is really exciting. And we have a RFC out there about that. But he's pretty early in that exploration. But we saw kind of a fun demo from him just this morning where it's showing up now on Washboard, which is like a cool milestone. But let me show you a hello world with components. So with the component model, one of the coolest things that it gives you is the ability to work across languages. So it has basically ultimate language interoperability. And you might say, oh, I've always had that with JNI or CFFI bindings. And that's kind of true. Sometimes the way you have to do that is you have to have multiple processes. Maybe you had to manually create bindings. Usually it means it's a little bit harder to debug. And it's always these separate boundaries. And so with the WebAssembly component model, we have basically, in a lot of ways, like another language that defines how to go across these boundaries. And that's called lifting and lowering. But I would like to show it running first. So I am going to go into a host. This is not wasmCloud. This is all pure Bytecode Alliance open source stuff. I'm going to say cargo run. And all it prints out is a gopher that says hey and a crab that says hello. So that part is kind of simple, but but let's dig into a little bit on the guts. Inside our Rust crate for the Rustation. This part might look mostly familiar for folks because I think most of us write in Rust. So it takes in a string and it appends to that string and just says hello. And so the purpose of this demo is to show being able to take WIT IDL definitions and pass in high-level types like strings, which we weren't able to do before with WebAssembly modules. Everything is basically a U32 in WebAssembly modules. I'm able to pass that through all the way, and so I can have a couple different critters. This critter is a gopher, and little gopher says, hey. So same thing as the Rust code, I'm able to pass it in. And so what I think is pretty cool is that for the most part, I'm writing idiomatic Go. I'm using Go generate to generate these language bindings. And so the script for basically building something like this, if I go into my guest side of things and step into Go for Jordan, this is for you. I run Go generate. And then tiny go, I target WASI. So I target normal WASI preview 1 stuff because basically no language today supports WASI preview 2. And WASI preview 2 is where the component model is implemented for the first time. And so if I were to print that out and say, okay, what did I actually just do? Let's look at gopher dot. Don't say that. Gopher dot what? Then you'll see that the thing I just built was a module. And like I said, with modules, a bunch of numbers in a trench code. And now the next step is to take this WIT file that I created, this WIT IDL definition of the API, which is a hello world, basically a string print line, but put this interface definition inside the module that I created. And so to do that, I run wasmTools component embed, pass in the WIT definition, and the next step is a little bit more interesting. So this is adapting. Let me see if this works because I don't think I set the right place. Okay, cool. Takes a component adapter. So this is actually a WASM module itself, but it takes a WASI preview 1 module and adapts it to now match the component model. So if I do the same thing that I did before by doing wasmTools print on my component WASM module, WASM component, not a WASM module, when I open this up, what I'll see is that I actually got a component out. And that's pretty handy. And you can tell it's a component because it now has instances. It talks about using interfaces, streams, a lot of new things that are available as part of WASI Preview 2. And at the very bottom of this, you'll see what my exports are. And the export that I'm able to call is the component greeting example. And I'm able to call a function called hello. And so that's why in my top level component that combines both the, well, jump to it, both the Rustation and the gopher here, I am able to call each one of them. So I'm able to call my gopher component, my Rustation component from one top level component for each of those. And without really any extra code inside my application code that's able to benefit from these libraries written in any language, I can call them seamlessly and all in the same process. And I think that's pretty stinking cool. So here's your Hello World components, which is now available for the first time in WASM Time 10. I'll be announcing that in the Bytecode Alliance community stream on Tuesday, but everybody here gets an early preview. I'm done.
Bailey, thank you for, I got to see this talk in person. So I've definitely taken a look at this before, but I really appreciated the, actually looking at what like the WebAssembly module looks like in the text format afterwards. And, getting to look at the interfaces and, really what this is low level. And I know that there's a whole other discussion around what this will look like when you actually get to using tooling to interact with components. But I want to make sure that I don't monopolize the time as usual with all the questions. You actually got one in the chat, which looks like you already responded to.
Yeah, and obviously, Brooks, you saw the full talk where I had 40 minutes to spout all the wonderful things about the component model. So you guys got a speed run of all of that. I hope you stayed in and I didn't blow you away too fast. But this is my host code. So wasmCloud has a host, and it embeds a WebAssembly runtime, wasm time, as the question already implies. And so for this one, I'm able to show that I use one config. I said a couple new things like, hey, the WASM component model is available. So you set that to true. And then I directly am passing in my .wasm here. I can also show how I'm able to do this straight from Watt. This was the simplest Watt that I can come up with for defining a component. So touching back on what Brooks was saying, I think it's really interesting to talk about how a component is really a bunch of WebAssembly core modules underneath. So I call WebAssembly modules a bunch of numbers in a trench coat, and then a component is really a bunch of WebAssembly modules in trench coats pointing at each other. And that's really the trick, is figuring out how to lift and lower types between something like this that's adding 5 to the thing that's passed in, and being able to have basically a component A and component B, where I'm able to add that number to both of them. So I instantiate and then I run. My run function is the thing that just adds 5. So this might be a little too binary stuff, so I didn't run this one in the QCon demo, but the purpose of it was to kind of show that by creating a single instance of a component, it has all of those other components inside it. And so then when I say run, I run that top level function run, and then that's what's giving me that result that prints out. And so if I jump back to the Rust creates app, you'll see that I have this run function, and that's what I'm calling at the top level. And so my host code knows to just directly call run here for the demo. Looks like we might, is there a roadmap for talking to another WASM time? I think if you want to have multiple host instances working with each other, you should use something like wasmCloud. It's a really great tool to distribute and orchestrate having multiple WebAssembly instances. Having multiple instances talk to each other isn't too hard in that if I modify my host code here, right now I said, hey, get one instance instantiated with that component. I could have another one instantiated with that component, have, call one run function, call another run function, and then, add them together. But it's my host that's doing that gluing. And so in wasmCloud, the way that we do the gluing between actor components is over basically RPC calls.
Bailey, you can correct me if I'm wrong, but just along the lines of the same question. I remember Luke giving a talk last year at KubeCon in Detroit and was talking about the component model. And I seem to remember him saying that distributed components were explicitly out of scope for the component model proposal. I don't know if that's, if there's going to be more later, but is that right? Am I remembering that right?
Yeah, that is explicitly out of the scope. And if you go to the goals of the component model within the component model repo, that's stated as a non-goal. Like, that's explicitly out. Things that are in is being able to have support for async and streams, which is going to come with WASI Preview 3. So the stuff I've been talking about is pre that this is Preview 2. But there's no reason why one host can't have multiple instances of a component and then figure out how to wire them together. That's not too bad. A couple more lines of my little Rust host here. And if you want it to play around, you're welcome to grab it. I dropped it over earlier in our chat. I'm gonna drop it again just in case. Just know, hey, it's hello world. I committed it when we started this meeting. So there might be some weird things in there.
Okay, awesome. I just wanted to make sure I posted that on the YouTube as well, so everybody could get that. Let's see. Vance, you had I'm actually not familiar with CXL, so maybe it's something that somebody else knows about around linking different components together or runtime.
It's about distributed memory, so it's a little bit futuristic. Let's leave that for now.
Oh, just a quick question on that. Would you actually do you have to implement software? I guess because it's in memory, you would literally have to implement it at the software level. Does it end up in the kernel in Linux?
Sorry, who are you addressing that to?
About CXL. So if you're like, I don't know what the libraries are like, how you would use it. But like, is there like a 2-minute summary?
CXL, what CXL does is it's an extension to PCI. So it uses PCI, it runs over PCI, and it distributes memory. And so what you're able to do then is have code executing on some CPUs over there, use memory that's available over there, right? And you can, it's just memory. It's just addressable memory, and that's how components share, right, with memory. So what you need is a runtime that knows how to orchestrate that, and so that's a big if.
You just gave me something new that I want.
Well, I think we all want it, but it's probably 10 years away. But it's coming. Check out CXL.
Yeah. At great risk of a rabbit hole, I'll probably propose we move on to the discussion. It does sound cool though. So we have one more thing left on the agenda for today. I wanted to leave a little bit of time for people to share their thoughts and kind of chip in on a brainstorm around secrets in wasmCloud applications. I believe we kicked off this discussion first on an issue in the WADM repository. And, we're kind of talking about taking a secret, whether it's from an environment variable when you apply like an application manifest or just generally a secret value that you want to use within wasmCloud. And I want to talk about a couple of different areas around like the security of using a secret value, because I actually kind of ran into this use case and I'm not quite satisfied with what we have right now. And so I'd like to, why don't I go ahead and start by showing that. So whenever we release Wash, what we do is we publish a tag in the Wash repo, and then we have two repositories for Homebrew and for Chocolatey, where we basically have to update a SHA and then update the version and then push to those package managers. And they both kind of require their own little special format for the repository and a special payload, and they have their own process and all of that. And of course, the people, all of us who are on the maintainer side of wasmCloud are a little more interested in trying to work on features and new things for wasmCloud than trying to make the perfect way to distribute to all the package managers. So when I wrote the webhook thing for OCI URLs, I actually started by trying to make an actor that would call the GitHub Actions API to basically trigger an action in a different repository. What would be cool is if I could basically take the existing release process, and as soon as the Wash release finishes, we say, hey, go call the Homebrew and the Chocolatey repos actions to kick off a release with the new version. GitHub doesn't natively have support to trigger an action in a different repo, but you can do it with an action with something called, what is it called? It's called the workflow dispatch trigger, I believe. I'll have to double check on what I started handling. So here's the actor that I actually started writing. Very creative name, Wash Releaser Webhook Actor, but it has a really simple thing that basically whenever it receives a post request to /API/homebrew, we take the tag. With the idea is that after we publish a release in Wash, we send a request to this actor, and then it will form an HTTP request to say, hey, go in the homebrew wasmCloud repository and kick off an action. And the way to do this is really simple. I took the example from the GitHub API docs. You basically just say, hey, I'm going to send you some JSON. Here's the GitHub API version I'm using. And you can send whatever information you want with this request. So I'm going to send, the body. All I'm doing is I'm just going to send the tag. I could send additional things like whether or not to just create a pull request and then, or just like dry run it or something like that. But the key thing and exactly where I stopped was right here. So in order to actually tell a repository to kick off an action, you have to have workflow permissions in that repository. Even if you could set it up to be public and not require this authorization, that would just mean that anybody could come and kick off a new release of Wash from an arbitrary tag, which at best will just not work, and at worst may release like a new version of Wash that we weren't intending to, or a broken version to homebrew. So you need a bearer token. And so of course, I'm not just a general note for people who are working in WebAssembly who may not know this. Whenever you create a WebAssembly application, you compile it to WebAssembly, everything is included in that app. So if I were to create like a secret constant and call it, I am a secret, and we compile this WebAssembly module. I don't actually know if you can directly find this out or not. I think I have this. Release or webhook. Watch.wat. If I look at this, the actual wat, maybe you can't find the code directly, but effectively, whenever it's probably because it's not used, and so it's getting compiled out. So if you put a secret into the code here, if I were to just directly inject my token, even if I kept everything closed source, the fact that this is a WebAssembly module, anybody can download it, they would be able to see my secret. So, that kind of brings us to the status quo around, okay, what do you do then? If you have a secret value, it's in an I-32 form. Okay, cool. Thank you, Billy. I figured that makes sense. So if you actually have a token here, my next thought is, okay, well, I'll just take the token and I can store it in a secrets provider like HashiCorp Vault. And then here, right before, I can use a key value sender, and I can, thanks, Copilot. Yeah, nice. I could like fetch the secret from the key value sender and get it out of a secret store like Vault, and then should be good to go. But one thing that I noticed after that is that even if I were to put the secret into a secret store, and then I fetch the secret out and I use it in this header, when I send this HTTP request, it doesn't actually originate from this actor. What it does first is it sends an RPC call over NATS, which then makes it to the HTTP client, and then will send out that HTTP request for me. So as long as I trust the HTTP client on the other side, then that's fine. But it will definitely it will transmit the secret over the NATS connection, which by default is really protected. When you have the RPC connection in wasmCloud, you can enable TLS. Depending on the setup that you have it, be protected by keys. So this isn't exactly a public connection that you could snoop on, but it certainly increases the radius that people are, moving a secret around. So I wanted to approach this from the wasmCloud developer standpoint of, I have this secret value that I don't really want to treat like a config variable. It's not just having a GitHub personal access token is actually a pretty permissive token, depending on how you restrict the scopes. And there were a couple of good ideas. I brought this up in Slack briefly. I know that Kevin had a good idea around how basically what one of the things that I could be asking for, one of the possible solutions is taking something like tokenization and making it a first class aspect of the lattice. So you can take a secret, you can put it into, and then it'll effectively turn it into a token at whatever entry point, and then you pass that token around, and only when you need to use that secret does it get transformed into the real value. This is a pattern we used to use all the time on one of my old teams at Capital One. But there's many different use cases here, and so I wanted to open up the broader discussion around some ways to solve this specific problem. And if anyone has worked with an app before in wasmCloud and tried to use a secret in this way and found that it wasn't enough, I wanted to leave some open time to chat about that. Hey, Patrick.
Hey, yeah, so I guess this has been fueled a little bit more by my experience with other secret providers, other systems that, you know, whether it's LastPass CLI or OnePass CLI, and using it with configuration management systems, or it's, you know, the Kubernetes, oh, I'm gonna lower my hand since I'm talking, working with like the way that Kubernetes used to do secrets and then has added support for it. I started writing like a little bit of an RFC, or just trying to write down my thoughts on how I think they should work. And I guess the big question that I have for you in like your experience with it is like that last thing that you just said just now, where you've worked in other teams where you pass a reference. Is that, I guess, from the actor development point of view, like looking at your code, the way you did it, it seems really nice. The idea that you could like, I don't even want to think about it. I just want to tell this provider, like when you're actually executing the request for me, just go look up or see if you can get this value. But the question that pops up for me is, one, does that feel that good that we want it that way? And two, does that mean that we discover exceptions and missing secrets at runtime?
Yeah, it's a great question. So maybe just to form it right around this specific use case, basically like the exact permission that I would want is, you know, what this secret value, I only want it to be present on the HTTP header when it's going out on the HTTP client request. Like I don't want it to be a real value as I'm fetching it out of the secret store. I don't want the actor to be able to log the real value. I don't want the provider to be able to log the real value. I just want the provider to be able to take it, put it on the header, and then send it out. And I think actually controlling that so that the provider couldn't access the value directly, but could use it for the purposes that I intend is probably a little harder. I could see us getting into really fine-grained control of secrets, which is probably a good idea. But I don't want it to be too hard to use. Mm-hmm. I guess the only other comment that I would have there is that specifically, I don't want to have some kind of config where I can create a secret for this actor or maybe a collection of actors and make it so that every single capability or every single thing that can receive an RPC call from this actor can access that secret. I feel like we get into the same problem with the whole analogy of the keys to the kingdom that we have now with capabilities in open source projects, where if you give an open source library the permission to access files, then all of the, you know, libraries that library depends on has the same permissions that you gave it. And I don't want to fall into that trap because it's very antithetical to what we're trying to do with WebAssembly.
Yeah. So the RFC I'm working on, how would we submit, or how should I submit like a stab to wasmCloud at like trying to define something?
Yeah, I think, or Bailey, did you want to go ahead?
I really like what Kevin did most recently, which is he started with a HackMD and he kind of shared that around, and he iterated on it a whole bunch and came up with a totally different solution than what he initially proposed. That's like really simple and really good. And then I think the process is put it in a GitHub issue on wasmCloud, and label it RFC, like some of the other ones that specifically Kevin's been putting in. I really like that, because then an RFC, right, is a request for comments. So the goal of putting that out there is to get more feedback from people that are in the community that are using it or thinking about using it. But I find that starting with a HackMD is a lot easier way to collaborate for that initial stab at something, because that initial stab tends to evolve a lot before you get to somewhere where it's like, okay, let's talk about this specific thing now.
Sweet. Yeah. So my basic idea, Brooks, was have secret providers actually be a first class. We've got link defs that are first class, actors, providers, and I think that we need both. As I was going through it last week and I was trying to just noodle on it, not only do we need secrets as a first class thing, but I think we actually need secret providers, because then you can hide away stuff like, I'm doing local dev and I just want to access an environment variable, or I'm doing local dev and I want a plain text secret that lives, I can create it and it lives in this single instance that's not available over a lattice, because, by the way, I'm a single node and I'm not distributed NAT. So just store it in RAM in plain text for me. Or like you said, a file. I think this is very similar to when we did local file start for the actor, and it was there is a subset of this feature that it really makes sense for local dev. It really makes things move quicker for me. But when you go to prod, it should be turned off by default. Never use this version of that thing unless maybe you know what you're doing or you feel like you know what you're doing. And then, so I think when you create if you had first class secret providers, and then you could create secrets that are of a specific type in that specific secret provider, then we could then take that, and at link definition time or at provider config definition time, we could effectively reference those, and then everything kind of has its own domain. That's my general idea right now.
Yeah, I think that makes a lot of sense. Thank you, Patrick, for kind of running with this. I'm glad this was kind of in the back of your head. I think you have a lot of really good thoughts around how we should manage secrets in this way. I really wanted to I think Kevin is going to probably talk about this, but I think the difference between getting something working locally and iterating in that way where, maybe when I'm just unit testing the actor or throwing something together, I'm just going to put in a fake GitHub token and I'm just going to make sure the whole flow works properly. Would love to be able to do something like just set up an environment variable when I launch the host, or, basically inject a secret into the maybe we use something like a Nats KV bucket for, basically old Kubernetes secrets where things were base 64 encoded, but not encrypted, not really secrets. And then I do want to talk about, in terms of when we have secrets, a secrets provider, what we would connect to, but I'm going to raise my hand and let Kevin talk, because I think that's kind of a different subject.
Yeah, so I think there's a whole bunch of really good stuff here. What I think we probably should make sure we do is separate the different types of use cases that we need for secrets. So one that I think we've been talking about is where I've got an actor that needs to make an HTTP call to some API, and I need a bearer token to put on that call. And so where do I get that from as an actor? And in the simplest case, we can just use the vault provider that we have that implements the key value contract. So if your key store is something that can be exposed as though, or if your your secret store is something that can expose a key value style API, then that's a fairly easy thing for actors to go query, because then you set up a link definition, the actor can get the secret, nobody else sees it, you can control all the permissions based on link defs. So that's one type of secret. Another one is where you need the information as transmitted to remain secret. And so I think that's a different problem with a potentially different solution. And so I guess where I'm trying to list off use cases, what I'm trying to, and Patrick, you can probably enumerate this, is when would you need something like a secret provider that exposes secrets to things on the lattice versus a capability provider that exposes secrets through one of our already well-known contracts?
Do you is it cool if I answer that, Brooks? All right, sweet. So yeah, I guess you can always, in my opinion, I think you can always, implement direct calls to a secret provider, a capability provider for a given secret store. But I think it gets away from our boilerplate free kind of value that I think that we have in wasmCloud. And so, like to me, that's the definition of boilerplate, is like, I just need a value so that I can talk to this thing. And like, I want to focus completely on talking to the thing. So I don't disagree at all. And when I put plus 100 in the chat, I totally there's no reason why you can't do all this stuff today with either a custom capability provider or even the Vault one. If you're using Vault, yes, by all means, use that to grab your secret and then make your call. I can't think of any reason why you could, if that was the pattern, and even if you had amazing code generation that just made that trivial, you could always use a capability provider. I do think, though, there is value in when we talk about the speed of things, or we think about performance, not having to do that call across the lattice to get that secret. Basically, if you're co-located with a machine that has a Vault, has the Vault secret provider configured, and by the way, that Vault secret provider, because it understands that caching is a thing, it can cache that secret, and it knows that secret's going to expire in 30 minutes. But by the way, it's in RAM already, so you can just make this call. I think things get a lot faster, and it gives us the ability to be more performant in specific cases. But yeah, there's nothing. I think your point is what do we actually get by doing one versus the other? And I think it's purely, does it provide enough value? That's a very good question, and I don't think that we're limited today, that you can't do stuff, if that makes sense.
I think that makes sense, Patrick, and along the lines of what Jordan just put as a comment is actually exactly what I wanted to talk about too. What he said, and Jordan, you're welcome to talk about it too. It's talking about WADM rescheduling an actor to another machine or something like that. It's really important to differentiate between the local development, I'm just trying to get it done, I want to test the functionality and then move it to prod later, and that's what wasmCloud does so well. And then, the real solution when you're running this application in a production type environment, people have so many different solutions and vendors that they use for a secrets manager. It's not just Vault. People use AWS Secrets Manager all the time. Being able to manage those permissions with your other parts of your application especially in the cloud ecosystem, is really important. And so I know that there's going to be a little bit of an inverse relationship right when we start on just making something work as easy as possible locally for iterating and creating something generic enough that people can bring their own secrets provider. So whether it's Vault or Secrets Manager or other clouds, Secrets Manager or Key Manager, anything like that. So it has to plug into existing secret stores. And I just want to be super clear, and anybody can correct me if I'm wrong here, but wasmCloud isn't really trying to be in the business of implementing a secret store. We don't want to be managing the complex details around caching secrets, making sure that they're super safe. Like, there are very well defined and very well implemented solutions for this already. So my whole goal for this discussion is to get exactly what I think Kevin is pushing towards, which is let's get some use cases down for when we want to be able to use a secret, and see if we can go from there for implementing with a secrets provider. Maybe Vault to start, but having it generic in a way would be great. There was also a comment on our live stream about how taking a secret essentially just in time from a secrets provider and then making a request to the secret store and then tokenizing it over NATs is a pretty sophisticated use case. And as much as I want to have the most secure solution as possible, I want to have something that doesn't incur such a penalty for running applications. So I'm really interested to see what we can come up with as we keep talking about it. And Bailey, did you want to say that on the call? I think that's a great place for us to tie it all back to, no matter what the implementation detail is at the end of the day, what the developer experience feels like.
Yeah, I mean, I think my perspective on it is really similar to Patrick's in that I have some Kubernetes goggles sometimes when I look at things. And one of the things that I really liked with Kubernetes was that I had a place where I defined what my secrets were. And I see a logical place for how to do that on some of my link definitions. Obviously, I don't want to put my secret plain text in the file, but I would like to say, hey, I have a secret and it's this key. And then something figures out how to use a secret manager, whether that's through a capability provider or something else, but links all of that together for me as a developer. Like, I want to be able to say what my secrets are. And I might not even be the person that has the powers to like mess around with secrets. Somebody else has set that up for me. But as a developer, I just know those are certain things that I need to be able to run my software.
Yeah, I think as we start to see like changes in performance, not having to, I think the overhead of calling out to a provider, which then possibly hits local cache or possibly hits whatever, secret store it's trying to talk to, which could be, I'm thinking of an annoying case where it's like AWS CSM, or I forget if that's what you call it, the right service name, but like it reaches out to AWS, but oh wait, it's in a different region. And so now you've got a 200, 400 millisecond lag on just getting the secret. And by the way, that secret provider is, I assume if we get more maintainers, the AWS ones will naturally get more attention just because AWS is so big. But say it's like, I don't know, pick a service that just doesn't have as many users. For those folks that like, they either have to go implement caching themselves to get benefits there and be able to store stuff a little bit closer, or they're literally eating 200 to 400 milliseconds across the WAN every time they go to look up a secret. So I think, I don't know, you can make the argument that, well, then the capability provider should implement caching itself. And then we leave it up to the user to schedule a capability provider in the right area. But we're getting into like all the real world, like the internet is not actually right next to me. It's over there type stuff. Sorry, my brain is rambling today, but I just think that it would be amazing if part of the washboard was like, oh, just go define these things over here, and then when you go to schedule your actor, it just, to me, it feels like I want to reach exactly for what you were saying, Bailey. Like, oh, there's already a secret to find over here in this, I don't care if it's encrypted right now. I need to get stuff done. Let me just link to that in my actor and I'm good to go. That type of experience is what I'm imagining.
I was gonna say more, and then I noticed that we were kind of running low on time here. We're even past the time. But I think that this was a really awesome discussion. Really glad that you were here, Patrick, to kind of steward this up, and I'm looking forward to seeing the kind of the RFC / pre-RFC that comes out of this. Bye, Billy. And I think we can chat more then. If anybody else has any other feedback on the whole idea of managing secrets or even like config type secrets, please feel free to continue the discussion in Slack. Or if this is something that you want to keep talking about in the community meeting, we can always add it on as another agenda item for next week. But I think for now, this probably wraps up this community meeting. So I'm going to go ahead and stop the stream. But thank you, everybody, for coming and tuning in and asking really awesome questions as usual.